Hello everyone and welcome once again to my channel. Today we'll be looking at how to solve expressions which involves conjugate of a binomial surd. We're going to learn how to solve expressions or questions that involve conjugates of a binomial surd. I know that some people will be wondering what is a conjugate of a binomial surd, but that's what we want to look into right now. Now, an expression may contain two terms. An expression may contain two terms. For example, we have something like this, 6 minus root 2. You may also have something like 3 root 2 plus root 5. You also have maybe 3 plus root 5. You can see that these are expressions and they have two terms. This one has a whole number and has a surd, while this one has two surds, while this one has a number and a surd. Now, if one or both of the terms contains a surd, it says if one or both of the terms contains a surd, we call this a binomial surd expression. So what we have on the board now is what is known as a binomial surd expression, because it's an expression that contains two terms in which at least one of the terms is a surd. Okay, now to rationalize a binomial surd, we use the idea of the difference of two squares. For example, to rationalize, let me clean this up. For example, to rationalize this expression with a plus b, we multiply it by root a minus b to get this, root a squared minus b squared, which is a rational number. Okay, so here's the idea. It says that if you have a binomial surd expression and you want to rationalize that binomial surd, what you simply do is you use the idea of difference of two squares. Now in difference of two squares, we have, it's already here on the board, we have something like this, which is this and this is now equal to a plus b in bracket, and we have with a minus b also in bracket. This is the formula for difference of two squares. And since for you to rationalize a binomial surd, you're going to have to multiply it by, another expression which is similar, but the only difference is that if the first expression had a positive in the middle, a positive sign, then the second one you're multiplying it with will have a what? A negative or a subtraction sign in the middle. Okay, now let's go on. It says this number in which you are multiplying the given number by, this was the first number here that was given to you, and now you want to rationalize it, so you now multiply it with this. Now this number you're multiplying it with is known as what? The conjugate. The conjugate of the first expression. This was the expression you were given initially, and now they now say, okay, I want you to rationalize this expression which is root a plus b. So what do? You now multiply it by its conjugate, and its conjugate is similar to what the original expression is. The only difference is that what here was positive, and now you now multiply it by its similar expression, but you only change the positive to negative. So now this is the conjugate of this, while this is the conjugate of this. So that is how we get the definition for both conjugate and binomial swords. So let's look at an example on the board that will give us more clarity and understanding. Now, evaluate the following. Evaluate the following. A says 2 root 3 minus 4 in bracket, and we also have 2 root 3 plus 4 in brackets. So we're supposed to multiply these two expressions together. Now, if you look very carefully, you will find out that what we have here is an expression of the difference of two squares. In this first bracket, we have 2 root 3. In this second bracket, we also have 2 root 3. In this first bracket, we have 4. In this second bracket, we have a 4. But the only difference here in both of them is that in this first bracket, we have a subtraction sign, while in this second bracket, we have a addition sign. So now, this is a perfect example of the difference of two squares. So what do? All you have to do in this case is that you express these two as a difference of two squares. So now, what you want to write is now writing this, and then you now express this as a difference of two squares, which now give us 2 root 3, the whole thing in bracket, raised to power 2, minus 4 raised to power 2. So this is equal to this, while this is equal to this. That is the formula for difference of two squares. So now, for here, you now have expressed as a square 2 root 3 times 2 root 3 in bracket, and you have minus 4 times 4. So raise 4 to a square, 4 times 4. So here, when you multiply this, you're going to get 4 times 3 minus, here will give you 16. So now I have 12 minus 16 is giving us minus 4. That's our final answer. So you see how easily to solve that when you apply the difference of two square method in solving conjugates of a binomial solve. Now let's go to the second one. This one is a bit like a fraction, but as you can see here, it is a binomial solve. Both the numerator and the denominator are binomial solved. So now in this case, what do? We're going to rationalize the denominator in this case. And how do we rationalize the denominator? By multiplying both the numerator and the denominator by the conjugate of the denominator. That is how we're going to simplify this expression. What we have in the numerator is a binomial solved. What we have in the denominator is also a binomial solved. But now I want to rationalize it. So how do we rationalize it? We rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. And of course, we know the conjugate of the denominator is something that looks like this. The only difference is that we're going to change this subtraction to addition. So this is what it's going to give us. It's going to give us 2 root 3 plus 2 times the conjugate of this, which will be 2 root 3 plus 2 all over what we have here, 2 root 3 minus 2 in bracket 2 root 3 times its conjugate, which is plus 2. Okay? So this is how it's going to look like. We multiply both this and this by the conjugate of this, and the conjugate of this is 2 root 3 plus 2. So now we expand. Now when we expand, of course, we know how to do this. It's like solving questions involving brackets of swords in brackets. So you know how to do to say this times all of this times all of this. So let's go. 2 root 3 times 2 root 3 will give me 4 times 3. Then 2 root 3 times plus 2 will give me plus 4 root 3. Okay, now we'll go to plus 2. Plus 2 times 2 root 3 will give me 4 root 3. And then plus 2 times plus 2 will give me plus 4. Very good. Now the denominator, 2 root 3 times 2 root 3, same thing, 4 times 3. Then 2 root 3 times plus 2 is 4 root 3. Minus 2 times 2 root 3 will give me minus 4 root 3. Why minus 2 times plus 2 will give me minus 4. Okay, so simplify all of this. 4 times 3 is 12. Plus 4 root 3, do it step by step so we keep up, plus 4 all over 12 again, that's 4 times 3 is 12 plus 4 root 3 minus 4 root 3 minus 4. So now you collect the like terms. You say this is the whole number plus this whole number, then this is another whole number minus this whole number. So here, let's put it here. Here you can now write 12 plus 4, that is, you bring this plus 4 here, plus 4 root 3 plus 4 root 3 all over 12 here, 12 minus 4. You bring this minus over here. You now write plus 4 root 3 minus 4 root 3. Okay, so now 12 plus 4 is going to give you what? 16. Then plus 4 root 3 plus 4 root 3 is going to give you what? Plus 8 root 3. Plus 8 root 3. That's for the numerator. For the denominator, 12 minus 4 is 8. Then we have plus 4 root 3 minus 4 root 3. Plus 4 root 3 minus 4 root 3 will be what? 0. So this is what you'll be left with now. Looking at what we have, some people say this is the final answer, but this is not yet the final answer because what we have here can still be simplified. How? The numerator has some common factors in it that you can collect the like terms from it. And those common factors in the numerator is what? We have 16 plus 8 root 3. 8 is a common factor of both 16 and 8. So you can now factorize by saying divide 16 by 8, you have 2. And divide 8 root 3 by 8, giving you what? Root what? 3 all over 8. Now this 8 can divide this 8, which means at the end of the day, your answer will be 2 plus root 3. And that will be your final answer. Now I know it looks a bit elaborate, but I outlined it step by step so that you won't miss a step, or you won't miss any of the explanation. In some of these multiplications, I could have just written the answers, but I just make sure I wrote it out so you'll be able to follow the steps I took in reaching the final answer. So in solving expressions that involve the conjugate of a binomial surd, the most important thing is for you to be able to identify those expressions that will lead to the difference of two squares, and also know how to properly multiply out your expression in terms of when you want to expand your brackets. Know how to properly expand the surds, and also take note of your negative and positive signs. And of course, if you do some more examples and of course watch the video over and again, I'm sure that you get a better understanding of how to solve questions that involve conjugate of a binomial surd. Now that being said, I've come to the end of today's video. If the video is very helpful, please do give a like and a thumbs up. Also, if you have any questions, drop it in the comment section, and also hit the notification bell so that you get notified whenever I drop my other videos. Thank you, and see you next time.